Hey, everybody, this is Mrs. Sullivan, and today we are going to talk about the properties of water. So, water is extremely important biologically, and it has a very specific bond that we are going to talk about called the hydrogen bond. So, a hydrogen bond is not super strong, so we're going to call it a weak bond, but its role in the properties of water makes water able to support the life that we know today. So when we have a molecule of water, like this one right here, we have two hydrogens and one oxygen, and the difference in the size of these atoms is showing us about their electron cloud. So one day when you take chemistry classes, you'll learn that oxygen has more electrons than hydrogen, and that it is going to have more protons than hydrogen as well. And so that's going to create an unequal sharing. So oxygen is going to hog all of the negative electrons. So it's going to have a negative charge or a slightly negative charge. That makes our hydrogens not have the electrons as much. So it's not a 50-50 custody in these bonds of the electron. And so they are slightly positive. Because they are slightly positive, they are going to be attracted to their opposite, which would be another slightly negative atom like another oxygen or a nitrogen. So a single hydrogen atom is shared between two electronegative atoms, usually the oxygen or nitrogen. So you could have multiple water molecules that are forming hydrogen bonds between them, or something like this NH3 here. So another example of hydrogen bonds, watered down, is just water. So these little ball and stick models, we have the red oxygens and we have the white hydrogens. And so each one of these represents a water molecule. And these little dots between a hydrogen and another water molecule on their oxygen, those are the hydrogen bonds. And so this shows how water is all connected, and that's going to explain a lot of the properties that we're going to see next. So your goal for this lesson is that you will be able to explain the unique properties of water and how those are important to living organisms. All right, unusual properties of water. The reason I'm saying these are unusual is because other liquids and other molecules don't have these abilities, and that is why water is so important for life. So when they're looking for life on other planets like Mars, we are looking to see that water is there because that is a foundational element of what we know life to be. So these properties that make water so special is that water is a good solvent. It is capable of doing capillary action. It has a high specific heat and a high heat of vaporization and high surface tension. These 5 unusual properties of water are going to explain what you saw in our water demos in your lesson last time. We're going to go into a little bit more about how each of these works. Then we have the expansion on freezing. So water is a good solvent. So in this beaker, we have salt. So salt is sodium and chlorine, and they are ionically bonded. When we put them in water, the sodium and the chlorine are going to separate. And so that is going to mean that the salt dissolved in the water. So it is breaking up in there. So if we add a solute to a solvent like water, so water is the solvent, what we're adding like salt is a solute, and we mix it up, we can get some separation of these ionic compounds. So why is water a good solvent? So water is a good solvent because of those hydrogen bonds that we already talked about. Water is also a small molecule, so only 2 hydrogens and 1 oxygen, much smaller than you see the chlorine atoms are much bigger. And a lot of our compounds that we talk about, like sugars, if you're dissolving sugars in water, those are really large. So water covers the surface of polar molecules and forms shells of hydration, which reduces the interaction between charged substances and fosters their dissolution. So what does that mean in English? So it means that this salt, when it's put into water, the water is surrounding the chlorine and surrounding the sodium. So you notice the oxygens are what's closer. So the red is closer to the sodium and the white is closer to the chlorine. And that's because of that charge that we were talking about. Because it is polar, so the charge makes it polar, it is a good solvent for ions or sugars and proteins that have those polar groups. So this OH group is going to have a negative charge. We saw before that nitrogens can form hydrogen bonds because nitrogens become slightly negative as well. And so that allows our water to orient itself or turn itself to get the slightly positive charges close to a negative ion and its slightly negative charges close to a positive ion. Capillary action. This is our second unusual property of water. This is where water has high tensile strength. That means that water is able to resist a pulling force. This is due to the cohesion of water molecules, which is also, again, because of those hydrogen bonds. So cohesion means it is holding to itself. So the water is attracted to other water molecules and is holding itself really close. Water has about 10% of the tensile strength of copper and aluminum. So that means water is holding on to itself almost a tenth of the strength of copper and aluminum. So copper and aluminum we think of as pretty strong, like that's wires. It's the copper that you're using in piping. It's a solid, so it's pretty incredible that water would have that same, a tenth of that amount of strength being a liquid. Water also has adhesion. So it adheres or like sticks to other objects. So cohesion, sticking to itself, adhesion is sticking to other objects. And so that's allowing it to climb up the sides of these tubes in the picture. So it's holding onto itself and it's holding onto the sides, which is allowing it to be pulled up these little glass tubes. This is the same property that's happening in the xylem of plants. So water has to be able to get to all of the parts of the plant. And they don't have a circulatory system the same way that you and I do, where their heart is pumping our blood through our body. Instead, we're using the properties of water and those hydrogen bonds to have the water be pulled up the xylem using cohesion and adhesion. All right, so water also has a high specific heat. Specific heat is the heat required to raise the temperature of a substance. We in chemistry talk about it being calories. So the amount of energy it takes to raise 1 gram of water by 1 degree Celsius. So when you get to chemistry, you'll hear that again. If we compare water to something like alcohol or to a solid like iron, we're going to see the amount of temperature that it raises is different. So water takes more heat to raise its temperature than most objects. It's going to take more energy to excite these water molecules and get them moving faster, because temperature is that kinetic energy of the molecules, than if we are looking at alcohol and iron. And the reason, again, is those hydrogen bonds. Because they are holding on to each other in our water, it is going to be harder to get them moving faster. So if we applied the same amount of energy to all 3 of these samples, water, alcohol, and iron, and they're all starting at the same temperature of 20 degrees Celsius, we would get only a 10-degree change in our water. We would get a 20-degree change in our alcohol, and iron would heat up a lot more, all the way up to 114 degrees Celsius, if we're applying that same amount of energy represented by our little Bunsen burner flame here. So why might this be important when we're talking about a lake? So lakes being large bodies of water, you'll notice when it gets cold in the fall and we see that steam coming off the lake, that is because the lake has not cooled down as fast as the air. The air changes temperature much more easily than water. And the bigger the body of water, the more they're able to hold on to each other, those water molecules with their hydrogen bonds, and resist the change in temperature. So the temperature of the lake is going to still be warmer even though the air has cooled off. This allows us to have a more stable environment. So if you think about fish, they don't like very fast temperature changes. It can be very bad for them. If you have an aquarium in your room, that's going to be something that if you change the temperature of the water really quickly, it can cause them to go into shock and to die. This is important because plants have no way to regulate their temperature. Biochemical processes are temperature sensitive and can be destroyed at high temperatures. Consequently, a medium like water that resists temperature changes becomes very important. So this is taking care of those plants as well as those aquatic creatures. They need that stability to survive. So now we're going to talk about high heat of vaporization. So vaporization sounds like a big scary word, but it's not actually that scary. So we're going to talk about the energy required to separate molecules from the liquid phase to the gas phase. So if you think of a vapor, right, that is a gas, and it's going to come from a liquid. So those are our states of matter. We have solid, then liquid, then gas, and it takes energy to move a liquid into a gas phase. So like when we think of boiling water, first we had the liquid, then it is going to move to that gas phase when we apply energy to it. So if we had some water and we had alcohol and they were both sitting in the sun, the water is not going to evaporate a whole lot. So evaporation, same thing. We're going from liquid to a gas so that some of this water would escape our glass and go into the atmosphere here. Now, alcohol, on the other hand, does not have the same property as water. It does not have the hydrogen bonds happening. And so it can quickly evaporate. Most of the energy is being used to break hydrogen bonds. That's why it's going to take more energy to evaporate water, is because we're having to overcome that weak bond between each of the water molecules that's holding them together. So an example would be plant leaves. So plant leaves are really important. This is the site for photosynthesis and transpiration, which is that gas exchange that plants have. So they are using CO2 and putting out oxygen in their photosynthesis process. And then they're using some of that oxygen for their own respiration processes. But we know that the net change is that they are releasing oxygen. So when we have our plant leaves, they can have a problem with overheating caused by extra solar energy. The water that evaporates from the leaves is an essential component of the regulation of leaf temperatures. So it's almost like when you are sweating and you're releasing that water, the evaporation of the water on your skin from your sweat is cooling you down. And so that's what we're seeing here with our high heat of vaporization. So a dog panting is also going to do the same thing. So dogs don't sweat the same way that you and I do. Instead, they do a panting, which again, they're trying to get that water to evaporate off their tongue and cool them down. All right, so now evaporative cooling due to high heat vaporization. So we talked about dogs panting. We talked about you sweating. Sweat is not really orange. This was from an old Gatorade commercial. But what we're looking for is that this water, when it evaporates, when it goes from the liquid to the gas form and it leaves, that takes a lot of energy, and that means it cools you off. All right, high surface tension is one of those really cool properties of water. It allows you to balance a coin on top of the water. It allows these little bugs that skate across the water to not fall in. There are even some lizards that can run across the surface of the water fast enough to not break that high surface tension of water. So the high surface tension develops because water molecules at the gas and liquid interface are attracted inward by hydrogen bonds to other water molecules and to those adjacent water molecules. So the hydrogen bonds are holding the water together. So they are resisting letting that other object, like the coin or the bugs, into the water. So our last property of water that is really special is that it expands when it freezes. So when we have water as a gas, so vaporized water, so this is like steam, the molecules are spread out, they're moving randomly, and they have a lot of motion going on. When we are in the liquid phase, those water molecules are a little closer to each other. So they're able to have those semi-ordered relationship. They have their hydrogen bonds that are helping hold them together. And so water is moving together like we think of fluids moving. But when we have solid water, those atoms are going to align to where your water molecule has the hydrogens that are slightly positive right up next to another oxygen that has that slightly negative. So they're making themselves all very ordered. And because of that, we create this spacing. So you see how even though they're all touching, you have these big gaps, and that's actually spreading out the water molecules in a different, more organized structure. We also call this kind of a crystalline structure that is going to give us some unique properties. So if you put a can of soda in the freezer because you wanted it to get cold really fast, but then you forgot about it, and then you have that dreaded moment, you open the freezer and it has exploded all over. That is because the water has expanded. It is very important for life that water does this. If water did what every other liquid does when it freezes and gets closer together, we would not be able to have aquatic life, because when ice is formed and it expands, it means it floats. It's going to stay on the surface of a lake. It's going to float up to the top of your glass. And this allows for the aquatic life to continue below the ice. If it were to do it the other way, if it were not going to expand, then it would sink and crush everything, and it would freeze more from the bottom up instead of the top down. So that's all that I have for you today about the properties of water. If you have any questions, please make sure to contact your teacher, and you're going to go back to our demonstration of water and fill in the after notes spot. Make sure that you complete all of those and have a great rest of your day.